Hey everybody, this is Larry. This is day 29, 3 days left of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Populating next right pointers in each node. Okay, so you're given a perfect binary tree where all leaves are on the same level. Okay. Populate each next pointer to point to its next right node. Okay. That's interesting. I am curious how I want to do it. You may only use constant extra space. I know that's a follow-up, but that's interesting. The recursive. Okay, that's kind of dubious. They kind of contradict. I mean, I know that they don't count it, but like, why don't you just say solve it recursively or something? Like because it does use the stack space, right? So it's extra space anyway, so it's a little bit awkward. Okay. Let's see. How would I mean, there are a couple of ways you can do it with like, what's it called? Level first search or whatever it's called. But I just call it breadth first search, right? And then you can do it that way. But I think that's the way that I would do it. But of course, it would take all of n extra space. And of course, that is not recursive, even though I don't know. This is a crappy condition because it's kind of weird. How would I do it recursively? Let me think about that for a second. That's curious. But, I mean, the left and the right, I guess that part is pretty straightforward. But then hitting the right, oh, okay. That's not so bad, I guess. Depending on how you want to do it. Because basically for each, I would imagine that for each node, you just return the rightmost of that level, and then the other side you return like the leftmost or something like that, and then propagate them up, and then merge them that way. Yeah, because you just want the rightmost of the rightmost of the left and the leftmost of the right, but I don't know. That's really awkward though. I mean, I guess that's fine, but I'm not gonna do it that way because I don't think like this. I mean, it's just a weird restriction. If you ask me, in the sense that I always count extra implicit stack space as extra space because you don't get it for free for sure, right? So it's a little bit or maybe a lot awkward for that reason. Okay, so I'm going to do a breadth first search. Feel free to do it with whichever way. This is supposed to be a medium problem, but to be honest, maybe when it was written, it was a medium problem, but now definitely a little bit on the easier side. Maybe not like a easy, but something that requires a little bit of practice. And after a little bit of practice, I think like everyone should be able to get this in a sense that like if you want to be interview ready, it is definitely on like below the bar, right? Like you have to be not only knowing breadth first search, but knowing how to apply breadth first search in other scenarios, more complicated scenarios even, right? So yeah. And there are a couple of ways you could write this. You can write this in like a level first search way as well. I don't actually do it that way, but yeah. Yeah. I'm thinking whether I can is there not any other way? I guess that's really it. Yeah, okay. I think that's what I'm going to do for now. So yeah, let's go. So then here, we'll start with a queue. I was just thinking whether ring, and then here. Yeah, and then we enqueue the root. And then now while length of queue is greater than 0, current is equal to queue.pop left. We want to say, let's actually also add in a parameter to make it slightly easier, which is to like just like the level here. So then now we can have current node. I just go node and level. And then the front of the node, the front of the queue is going to be the next node. So we can just throw if node or if level is equal to queue dot front. That's not the thing. Something like this. Then node dot next is equal to q dot 0, and then that's pretty much it. And then we append the next two, right? So yeah. So that's node dot left, level plus 1, and then node dot right, level plus 1. And I think that should be good. Do we return anything, or is it just it doesn't actually tell you, even though in the definition it seems like you should return something. So I'm just going to return the root. Maybe that's right. I don't know. It doesn't really say, right? Unless I'm missing something here. What? None, not. Oh, okay. Yeah, because here it goes into none. So I forgot to check if node dot left is not none. So technically this is a complete tree, so yeah. Yeah, I don't know what the thing isn't the root I don't get it. Isn't the root just the root? They don't tell you what to return, so it's a little bit awkward. Like, do you return the root? Do you return nothing? Nope. So you do return the root, I guess. But why is it giving me an issue? I don't even touch the root, right? This isn't a tuple, is it? I didn't change anything. This is way awkward, to be honest. This is not an error that is on my node, but honestly don't know what to do about this one, to be honest. Oh, is this none? Is that why? Okay. I guess I should have just done something like Not gonna lie, I don't know what this error is referring to. Because none of this is in my code, is in the thing. And they don't really tell you exactly what to return. Unless I'm misunderstanding it. And I don't really change root, right? Like, this is literally the root they give us. Like, I don't change it, so. I might change stuff in it, but I don't change the variable, right? So this should be the same type. Huh, so that works. That is very awkward, isn't it? Huh. And I know nothing. I'm like Jon Snow or something. Okay, so this is still... That's also weird though, right? Because... No, I guess this is okay, but when I do this, it's no good. Because is it because of stuff like this? Oh, I see. It is a Larry mistake. Though it's still very awkward. I guess this is one of those problems with, yeah, that's my mistake. This is actually one of those problems with Python is the type, the lack of type safety, because now node.next could point at anything, and even though I had a different type, which is a tuple, it still kind of was good for that reason. Whoopsie daisies. But yeah, let's try a couple more. Keeping in mind that it has to be, okay, this is it, because it has to be a complete power of 2 minus 1 or something, right? So, okay, let's give it a submit. Man, what a typo, but okay. But that looks good. 638 days down, done. Consistent is key, apparently. Yeah, so this is going to be linear time, linear space. Every node gets put in the queue once. Every node gets popped out of the queue once, so that's all one time, and we'll have one space for each node. So yeah, I mean, I don't think you can do any better, except for maybe with recursion, where you magically do not count the stack space. But yeah, though it is much more confusing, I think, if you ask me. But I wonder if you could play around with this idea of looking at one node at a time. I don't know. Anyway, that's all I have, I think. Let me know what you think. Hit the like button, hit the subscribe button. Join me on Discord. I'll see you later. Hope this week has been going well for you. Almost the end of the year, so let's make it count. Let's get those final days in, get those final reps in. I'll see you later. Stay good, stay healthy, to good mental health. See you later. Bye-bye.